Hi everyone. Today we are going to look at how to create a live table in Python. In my previous video, we have looked at how to create live table in R. So if you have not watched that video, or if you're interested in doing this analysis or creating this table in R, kindly visit the other video. Alright, so before we continue, if you have not subscribed to my channel, kindly do so by hitting the subscription button below. Also, if you find this video helpful, give it a thumbs up, hit the notification bell to get instant notification once new video is uploaded, and also feel free to drop your comment in the comment section. So quickly, here is my Jupyter notebook and I have the various codes here inserted. So the first one is import pandas as PD and numpy as NP. So for the pandas here, it is used for handling data structures, especially data frames, and for the numpy here, it is used for mathematical functions and operation. So we are going to run this using the play button here. All right, so now if it has run successfully, you would see one here. Now we are going to import our data. So my data is saved as live table data. So this is the same data I used for R while we are creating a live table. So I have explained the contents of this data. So if you need that, please kindly go and watch the other video. All right, so let's run this. All right, so it has successfully run. So we go to step 1, which is to sort our data by duration. So we are going to use the sort underscore values, and this method helps us to sort the data frame based on duration column in ascending order. So basically this is just the same thing we did in R, just using a different code. All right, so now we go to step 2, which is to define the live table structure. So in doing this, we are going to use the live underscore table, the pd.data frame. So what we're going to do here is to create a new empty data frame live table and also a column called time. And this our time we are going to also define the interval from 1 to 10 for the live table. So we're picking a range of 1 to 11 so that it will cover our range of 1 to 10. All right, so we are going to run this as well. So you see that the code is a little like that of R. You can also see that there's a slight changes in the code, but then we're still following the same steps. So step 3 is to calculate the number of patients at risk at each time. So we're using the code here. And so for this code here is going to create a loop iteration over the time column, and for each time this code here also helps us to calculate how many individuals in the data set are still at risk. That is have a duration greater than or equal to the current time from the code here. And also it's going to help to store. So it's going to be stored at risk column. So that is that for calculating the number of patients at risk at each time. So we're going to run this. So step 4. All right, so for step 4 here, we are going to calculate the number of events, which is deaths at each time. So for this here, this code here is going to provide a list comprehension. It's going to calculate how many deaths occurred at each time time point. So for the events here, observed 1 here means that yes, the event occurred. So that is to say yes, death occurs. So that is for step 4. So we remember we also did this in R. So we run this, we go to the next one to calculate the number of censored individuals at each time. We also did this in R. So the censored individuals are those individuals that the events did not occur. So such individuals did not observe the event, death. That is to say they did not die for that time duration. So we're going to run this and go to the next one, which is to calculate the survival probability here. So this code here would help us to calculate the survival probability at each time point. All right, so we just run this Then we go to the cumulative survival probability. So the cumulative survival probability here, this is the code we're going to use to calculate this. So the cumulative survival probability is calculated by multiplying the survival probability at each time step with the previous cumulative survival probability. So that is how we get this. All right, so now let's run this and we'll go to step 8, which is to calculate the hazard rate. So the hazard rate is calculated as the ratio of deaths to number of individuals at risk at each time point. So we're running this and we go to step 4 to calculate the standard error. So the standard error of the hazard rates is basically it talks about the variability. So we run this and finally we display our life table. So from our life table here, you can see that we're having the same result as that of R. We're having for time, we're having at risk, death, censored, survival probability, cumulative survival, and hazard rate, then finally standard error. So for time interval, we're having from 1 to 10. From at risk is the number of individuals at risk at each time interval. Death here is the number of deaths at each time interval. Censored is the number of censored individuals, those whose event was not observed, that is, they didn't die. Then survival probability here is the probability of at each time. Then we have the cumulative here, the cumulative survivor. This is the cumulative survivor. This is the cumulative survival probability over time. Then we have the hazard rate. Hazard rate is the rate at which that is the rate of events at each time. Then we have the standard error, which is the variability in the hazard rate. So this is where we are I'm going to stop this. So this is a very quick tutorial because we have had this previously in R. So if you wish to look at how to run this in R, you can check my other videos. Alright, so this is where we're going to be ending this tutorial.